And so a diffraction grating is our last diffraction interference effect. And basically a diffraction grating, we've made a little video of it. Hopefully you see it. It's taken us a little while to do it right. So diffraction grating basically is a lot of little slits is actually the way it works. And so the light comes and it's going through these slits. And here we're using the ray representation rather than the Huygens wavefront representation. But as these waves go through here, they diffract outwards. And at different positions, we're going to get different results. So here's basically the way it works. We're going to look at the rays that get diffracted in this direction. So you could imagine if you were doing the Huygens construction that you would be following two circular wave fronts out of here. Okay, so here's our little right-angled triangle right here. So there's our right angle. Here is the distance between the two slits here, which I think we're going to use x for. And so the hypotenuse is x. This angle is theta. And we're going to get constructive interference when the path difference is one wavelength. So depending on what color of light it is, when this little extra path difference is 1 lambda, we're going to get constructive interference. Okay, so this is the angle in our little right angle triangle here, and it is actually the same as the angle to our first bright fringe. And so this theta right in here is the same as the angle headed to our screen down here. And so the angle to the bright fringe is going to match up with the angle right here. Notice that opposite this angle is lambda, and so I just say, oh yeah, sine theta, and let's do the first bright fringe, is going to be equal to lambda, the opposite, over the distance between the fringes, the distance between the slits. And so this is also going to be the angle to the first bright fringe. Okay. Anyways, if you can imagine, if we carried this on, the angle to the second bright fringe is going to be 2 times theta over x, because now the path difference is going to be 2 wavelengths. And so the sine of the angle to fringe number n is going to be n lambda over x. And if you like, you can say x times sine of angle n times n times lambda. And so that's how we derive the equation. Once again, you're into that same old thing. How many wavelengths difference is the path? And this is our final diffraction interference effect that we're examining.